This is the Smart Buildings Academy podcast with Michael Roper here, and this is episode number 517. So welcome to the Smart Buildings Academy podcast. Today's episode will be about strategies to design submittals that aren't rejected. Now, all information that I'm covering in this episode can be found on our website at podcast.smartbuildingsacademy.com/517. Okay, so let's go ahead and start by reviewing the agenda and what we'll be talking about throughout this podcast. So what I'm going to do is I'm going to start off with just going over the understanding of the role of submittals. What's the purpose of submittals and why are they important to our BAS and HVAC projects? Now, after that, we're going to get into the cost and impact of rejected submittals. Maybe they got rejected once, twice, and hopefully not, but maybe even 3 times, and how much that can cost your company. Then we'll get into interpreting the specifications and design intent the correct way, and hopefully from the beginning when we're doing our design on the project. And then we'll get into some common reasons submittals might get rejected. Strategies to create clear and compliant submittals. Make sure it's clear and compliant. That way it's easy for whoever we're submitting to read these and approve them in a timely manner. And then we'll get into communication and coordination with all the stakeholders involved in the submittal process, leveraging standards and templates that you can use in your local office to help you streamline and make this more efficient process, review quality control before we submit. We're going to be talking a little bit about that. And then also something that's really important too is building relationships with the people we're submitting to. This could be the design engineers, or it can even be the building owners. And then last, we'll get into using some digital tools to streamline the submittal process. This could be like some software that we can use, some examples of that, and how that can hopefully make that more efficient when you're putting together your submittals. Okay, so let's get into our first topic, and we're going to talk about understanding the role of submittals. Now, submittals document how your building automation system and your HVAC system will fulfill the design intent, what was originally designed from the beginning. Now, this really dates to the owner, when the owner and the mechanical engineer meet for the first time, and maybe the mechanical engineer is putting together the HVAC design and the building automation system design, and they're working together. The owner's going to have the final say in it. However, the mechanical engineer is going to design it the way the owner wants it. Okay. So this is not just paperwork. This is like a contract and a representation of the system design. This is guaranteeing that we're submitting what we're going to provide to the building owner, what they wanted from the begin with, what the mechanical engineer designed with the owner. And this is just to make the requirements set in stone, to make sure these are the rules that we're going to follow to meet the customer's expectations. Okay. Now, a well-made submittal shows technical competence and it sets the tone for the project. Okay. So whenever, if a design engineer is looking and we're seeing a lot of missing pieces, that's not going to show very much technical competence on our side when we're submitting to the design engineer for this. And it could maybe set the tone for the whole project, maybe to go in a negative way. So a well-made submittal from the beginning is going to increase confidence in not only the design engineer, but also the building owner. Good submittals also reduce field conflicts and change orders by clarifying expectations early. Okay, if there's a misunderstanding within the specification, if there's some gray areas, this could be like maybe a device, maybe a communication protocol. It could be responsibilities of contractors and subcontractors. Maybe it's vague. Maybe we don't know if we're supposed to run all the power wiring to all the transformers, or maybe it's the job site electrician. So things like that need to be caught up front, and that's really an important piece to understanding the role of submittals. Okay. So that's kind of what submittals are and what their role is and why they're important on the project. It guarantees what was agreed on from the beginning when the design engineer and the owner met and they put together their system. Okay, so next we're going to talk about the cost impact of rejected submittals. Okay, so each time we have a rejection of our submittal, this delays project milestones. Okay, a lot of project managers they counted on the submittals being done at a certain time, and if that deadline's not met, that's going to push our project back. This can stall material procurement as far as ordering materials too as well. Okay, so think about the lead times, especially these days, with maybe some shipping issues, availability, things like that. Every day that's delayed, or maybe every week, that's going to cost more time on the project. Okay, every round of resubmission costs labor time with the project engineer or whoever's designing the project and producing the submittals. Could be the technician. Coordination effort, and also the credibility, because each time we get rejected, maybe the owner and the engineer might think we don't know what we're doing. Okay, so it reduces our credibility in that aspect. Repeated rejections strain relationships between contractors, engineers, and owners. Okay, so we're usually going to be a subcontractor to the mechanical engineer, and we're going to be submitting to the engineer, the mechanical engineer, and the owner's going to be behind them, kind of in the background, just keeping track on the project. But this can also cause a strain on our mechanical contractor, we're going to be a sub to them. They're counting on us to have our stuff ready to go whenever they lay their equipment down and they get the equipment start up, and that can delay their milestones on their project too. Okay, so that can cause strain on all the stakeholders in the submittal process. Now, we need to aim to submit once and approve once. That should be our goal every time. Okay, we need to make sure we have everything in there, double check, triple check if we have to. That should be the internal metric of quality within your offices. That way, obviously, it's more efficient, and our projects can stay on schedule. Now, proper submittals can accelerate project turnover and reduce rework costs down the line too as well. So that's another advantage if you have great submittals, and if they do get rejected, it could really cost you in the down the road there. Okay. All right, so let's talk about interpreting specifications and design intent. Okay. Now, we need to make sure whenever we're going through our specs, the specifications are going to be the rule book. Always start with the specs before you go to the drawing. This is what I usually used to do. Skim through it a little bit, make some notes, highlight some different parts of it that stand out. The gray areas, you might want to use a different highlighter. That's what I used to do when I estimated. If there's any RFIs, write them down, make note of those, and send the email out to the design engineer immediately. Okay. If there's any request for information, if there's missing information, or if you need a clarification on something, like it's kind of vague on whose responsibility it is to run the power wiring or whatever, make sure we get a clarification on that from the engineer in a timely manner. Okay. So also we need to break down the instrumentation and control section, the 230900, and the BAS sequences, which is another new section, 230923, within the new CSI standards. You might see that in there too. So make sure that we have the proper sequences, not only the right material and the coordination between trades. We also need to make sure that we have the right sequence of operations. Usually these are going to be on the control drawings when we produce those, and you're going to put that sequence of operation, and usually the design engineer is going to look at that, make sure it's in line with the original intent, and then they can approve it or reject it at that point. Identify mandatory versus optional requirements. Okay. Not everything is negotiable. All right. So we need to make sure if it's set in stone in the spec, we do it. If it's optional, you might want to just break that out as an add item or something like that. But mandatory, we need to identify what's mandatory and what's not. Okay. Watch for performance specifications that defines outcomes instead of hardware. Okay. This could be like energy, savings type applications or something like that. Okay, so this could be something in there too as well. They might have to reduce their energy consumption by 20% within a year, and you might have to put that in your spec or whatever. Cross-reference the mechanical schedule to ensure your control points and naming align. So if there's like a mechanical schedule and we see all of our devices on here, and they might have a one-line diagram too as well on those blueprints, make sure that the schedule is in line with your control points. Make sure you're picking up every device that needs to be picked up. And if there's any gray areas that are just kind of ambiguous and doesn't make sense, that's when we need to send out an RFI or RFC to the design engineer to get some clarification or some more information to make sure we cover those points. Okay. Use a highlight and comment approach. So mark key sequences. Okay. Make sure we mark these to make sure they're there. Make sure we mark key devices and also integration points. If there's any integration points, make sure we highlight that and we put some comments on there. If there's any special type of integration techniques that we have to do or the building automation contractor has to do, make sure that is named out there and it's out in the open. Everybody knows about it. Okay, so that's really important on interpreting specifications and design intent because if you don't go by what was spec'd, because this is going to be the rule book, the rules of the road, it will get rejected if the design engineer is paying attention, and you'll have to redo it to their standards. Okay, so that kind of wraps up that section there. Let's get into our next section, and we're going to talk about some common reasons submittals get rejected in the first place. Number one, incomplete content. Okay, you can have missing wiring diagrams, network layouts can be insufficient or missing parts of it, or you can even have control details that are not specified in there too as well. We can also have specification matches. Maybe we weren't paying attention to the spec and we're substituting hardware without approved equals. Okay, so please don't ever do that, especially if it's like a supervisor controller. If you're only, representing one vendor and you went ahead and won the bid, and for some reason you forgot to check and come to find out your supervisor was not approved from the beginning, this can cause a major reject, or I guess you could say a lag in the process. I was trying to think of a good word. I couldn't think of anything off my head. But anyways, this can really delay your project, and it can lead to a rejected submittal. Okay, and also you be without having any kind of hardware to put into that system. Okay, so be careful with substituting hardware without approved equals. Okay, now when the estimator or whenever the account manager is doing the takeoff, they might have got approval to bid a specific piece of hardware or a device as an approved equal, but that needs to be in writing, has to be in an addendum before you can submit your bid to your customers and let them have the confidence that you're going to cover everything that was required. Okay. Disorganized format is another one, just how the submittal looks. Unclear device legends on the control drawings is one example. Maybe it just doesn't make sense, or mismatched sheet numbering. Okay, so the sheets don't match up, the device legends don't. So just a weird format. The sequence of operation may be out of order. So things like that, they could cause it to get rejected just because the engineer gets confused and they don't have a lot of time to be sorting out and cleaning up our mess whenever we're submitting this to them. So just make sure it's in an organized format, nice, clean, and clear. That way it just makes it easier for them to pass our submittals. Poor coordination is another one. So for example, if the mechanical plan says AHU-1 and your drawing says AHU-A, then that doesn't make sense. That might not make sense to some people. I mean, they might think it's a totally different air handler. Okay, so that's poor coordination. Maybe that engineer gets confused on that, and then they'll just reject it and say, you need to make this more clear. All right, so just make sure that coordination is clear on your mechanical plans. Look at the equipment schedules, what those are named, and that's usually what we need to name that too as well. Okay, if you want to name it something else, you might want to get permission to do that before you submit it. Okay, another one is whenever we copy and paste generic sequences. Maybe we have a generic sequence for a single zone air handler or a VAV air handler, but the problem is they might not match the project's equipment or maybe even the project requirement on the sequence of operations. So maybe if you have one in your database for these and you just want to reuse it, but they might be missing some points or maybe maybe a duct static reset or something special like that in there that we have to add. You can always use a generic sequence that you have already in your database. However, just make sure you modify it to match the intent of the design from the engineer and the owner. Okay. Another thing, sometimes we miss compliance statements. If an engineer might not be familiar working with your company, or they might be unsure about the capabilities of the devices, sensors, and controllers you're providing, they might need to have a compliance statement. And this is where you can show how your design meets the specification paragraph specifically. Okay, if there's any gray areas that you anticipate that might get rejected, you might want to put a compliance statement. Say, this is how we comply with our supervisor because of this reason. Okay, or whatever it is there. Okay, so that kind of wraps up some common reasons submittals get rejected. Now we're going to go to our next section, our next topic, and we're going to talk about strategies to create clear and compliant submittals. It kind of feeds off when they get rejected. Let's talk about how we can prevent these from getting rejected in the first place by doing this. So creating a submittal roadmap is going to be very beneficial. Maybe you do this already. This is just like an internal checklist with all the required documents that we need. So think about all the documents that usually has to be submitted on. You can find these in the specifications specifically, but however, you're always going to need your cut sheets or your data sheets of all your sensors and devices, controllers, whatever equipment you're providing. You're also going to need your control drawings. On that control drawing, you're going to have controller detail drawing. You're going to have maybe some electrical wiring detail drawings. Sequence of operation is going to be contained in the control drawings, and so on. Okay, so make sure you have a checklist, an internal checklist with all the required documents. And if you can even standardize that, which we'll talk about here in a little bit, that would be even better to make a process for that every time. Maintain version control and document revision in your PDF set. If you revise your submittal, make sure that you know what was changed previously, okay, to current. Okay, make sure that version control is there. Put revision 1, 2, 3, 4, all the way to however many you need. But make sure you keep your older revisions and do not edit over the previous versions. Just make a new copy with a new version. That way we know what was happened in the past, and we can kind of compare it to what is currently being submitted. Use consistent device symbols and layer standards for clarity. So make sure that, if you're using a temperature sensor on a one-line diagram, it's going to look the same on every air handler. Don't use different symbols for different items on different pages. That can throw engineers off, and it could be unclear why we're doing that. Okay, so just be consistent. Summarize each control sequence in step-by-step logic that can be easily reviewed. Break it out to where it's easy to see. I see people writing just a run-on sentence forever. Okay, it can be like a million sentences all stacked together. Use those spaces in between sentences, make paragraphs. Break those out to make it easier for the engineer to read and review. Okay, our job is to get these submittals passed, and we need to make it easy on the engineer to read through these, and so he can have the information to do that. Include a points list with descriptions. All right. This is really important. This is good. This also helps the engineer understand that you picked up all the points that was required on the project. Okay. This can be analog inputs and outputs. It can even be like a network point. Maybe it's a BACnet IP network or an MSTP network, as far as networks go. Okay. So make sure we have a points list with point name descriptions on there. That stand out so the engineer understands that we picked up everything on the project. Highlight any deviations from the specification clearly. Transparency earns trust. So don't try to hide something or sneak something through. If there's any deviations and it wasn't picked up in the beginning and there wasn't an addendum issued, you might as well just highlight those from the specification. Let them know, hey, we're going to deviate here, just to let you know, and go with that way. Don't let them catch you, trying to hide it under the rug, because then you're going to discredit yourself and you're going to lose trust with your engineer and your contractor and the owner. Provide simple network topology showing the panels, field devices, and all the connections. Okay, so we want to have a nice system architecture page on our control drawings that shows all of our controllers connected, whatever protocol on the BAS network. Then also on the IT network, we want to also show that how it connects to the customer's IT network, so they'll know that we are fulfilling that requirement as part of the specification. Okay. All right, so that wraps up that section. Let's go to the next one where we're going to talk about communication and coordination with all the stakeholders in the submittal process. Okay, so building these relationships is very important, obviously, but we need to communicate early with mechanical and electrical teams. Okay, this could be with your design firm, or it could be on the job site with the job site electrician and the mechanical contractor, who's going to be our customer. They're going to sub us out and they're going to pay us to put the controls in. So confirm power, okay, with the job site electrician or your subcontractors, okay. So do that. Hold pre-submittal coordination meetings with subcontractors to avoid conflicts, okay. So even get with your subcontractors before you submit. Just make sure they're on the same page, and hopefully you got a quote so they can fulfill what we expect for them to do on the job site. So just keep that in mind too as well, to avoid any roadblocks in the future or anything like that. When in doubt, ask questions before the submittal. Don't just send the submittal and wait back for, answers. Okay. Ask questions, try to get these resolved before we submit it. This clarifies intent and prevents rework. Okay. Identify and assign internal submittal lead to manage communication with the engineer. Maybe you have someone in your office that does this a lot, and they could be the submittal lead. It could be a project administrator. It could be a project engineer. Maybe it's a BAS technician. Whoever's going to do that, make them the lead. Make them the person that's responsible for the submittal. Okay, because if no one's really the lead on it, it could be forgotten in a busy time that we have out in the field on a day-to-day basis. Okay, so make sure we have a submittal lead that communicates with our customers. Document all communications. This is important too, and I know it's not fun to do, but keep an email or RFI trail to reference during reviews. This is very important. If you got an RFI and you got clarification or approval to do something in an email form, you need to save that electronically, and also I would print it out and put it in the job folder. That way you have it if there's any issues down the road that we didn't uphold the spec or the plans within our submittals. Okay. So get that document all communications that you receive. Okay, let's talk about leveraging some standards and templates. This is important too, because this can help you streamline the submittal process and make it go a little bit quicker. So build a standard submittal package template for each system type that you might be doing on a consistent basis. This might be a single zone air handler. It could be a VAV air handler, a VAV box with reheat, hot water reheat, or electric reheat, whatever system it is, chill water, heating water system. Make a standard submittal template to what we're going to do each time we have one of these pieces of equipment. And then you could just repeat every time you have one of those projects. Also, keep consistent title blocks on your control drawings, sheet numbering, and naming conventions. This will help your engineers whenever you submit to them. They're going to be used to what you give them. So if they're used to seeing your control drawings and they know your title blocks, they know how you number it, the order that you put your control drawings in, and also your naming conventions, that would be good. Don't change it up, and because that can throw some roadblocks and confuse who we're submitting to. Incorporate pre-approved details. This could be like flow diagrams, control schematics, okay, on electrical detail drawings or something like that, and also point list. Okay, so we know what's on the blueprints, and then also on the specifications. Go ahead and get that down that we know. Okay. Align your format to the CSI Division 25 standards for professional presentation. Make it maybe look like that. Make it look like the submittal that's in the spec. I mean, that's what we're supposed to do anyways. That's the requirements and the rules that we have to go by. So make your format in the same way that whatever your engineer laid out in the division, in the specification. Use auto-generated document tables to maintain revision tracking and versioning. Okay, so a lot of times our modern word processing software applications can do that. So keep that in mind. So auto-generate document tables. Templates, in the bottom line, if we can get a template together, they're going to reduce the submittal prep time, and it's going to ensure nothing critical gets missed, hopefully, okay, during this process. It just helps the quality control and also helps efficiency when we do these things. So let's talk about reviewing and quality control before we submit. Now, it's really a good idea to perform an internal peer review by like a senior controls engineer. Maybe it's a project manager or controls technical leader or something like that. If they can be invited to a pre-submittal meeting, that would be very beneficial. They might be able to catch some things that we might not see out in the field, or see some challenges that we need to make clear before we submit to the engineer so we don't have to submit again. And then, like we talked about before, use a submittal checklist. Okay, you're going to get your sequence. You're going to get your points list with device count. You're going to get your drawings on there, your one-line drawing, your controller detail drawing, and any compliance verification that you might need to also provide to the engineer for submittal approval. Double check points list against the project's equipment schedule. Okay, don't just make your own points list up. Make sure it complies with what is on the equipment schedule. Okay, make sure it actually adds up there. Validate all I/O modules, sensors, and valves are clearly represented. Make sure we have the cut sheets or the data sheets on each one of those when we submit to it, if that's required. Also review BACnet object list, if there's any kind of BACnet objects that's required, any list, if the engineer is going to be checking for that. And also make sure it matches any naming conventions that is required by the BACnet objects too as well. Include a quality assurance sign-off sheet within the submittal to show it's been internally vetted. Okay, so maybe after your meeting, and we can have a sign-off sheet just to authorize it, and whoever that might be. It could be the senior controls engineer, or it could be the project manager. So we could do that on the QA sign-off sheet. And that's an internal process with your own internal team to do that as well. So, and the whole idea is to do this before we submit. That way it goes through once and it's approved once only. Okay. We want to submit it once and be approved once. Okay. All right. Let's talk about building relationships. This is going to be our last section here. And this is a really good one because you really need to build your relationships with engineers and owners. Okay. The goal is just not to get it approved, not just to create a bunch of paperwork, send it to them, get approved, and go start on our project. It's a mutual confidence. You're going to be working with these design mechanical engineers quite a bit, possibly even these building owners. Even post construction, you'll be maybe servicing their equipment. So it's a good idea to at least build a relationship with these people to create that confidence with each other, that trust that we have with each other. Okay, sometimes it's also a lot easier if you have a good relationship with the engineer. Maybe if, they can help you out on something, if your controller might not have a certain capability, or the building owner might be okay with it too as well. That's the ultimate decision maker, really, is the building owner, if it's okay in that area there. Now, engineers often remember who submits quality work consistently. So don't be the person that doesn't do it consistently, because they're going to really probably put a critical lens on your submittal and really go through it. They're going to be like, okay, what did this guy miss this time? You want to be the one that does quality work consistently. The engineer has confidence in your work, and he knows that when he gets your submittal, it's going to be well put together, and he's not going to have to take a lot of time to go through it, and he can trust your work that it's done the right way. Respond to comments professionally and quickly. This builds credibility. I teach my BAS technicians this a lot in some of the classes that I teach, how to send an RFI to an engineer if he has a question. So just, learn what an RFC is too, if you need clarification on anything. So that's something that's really important, not just verbal communication, also written communication is very important to have a skill in that area. Ask for pre-submittal feedback. If you're unsure of specifics, just kind of check in to see what the engineer thinks. Say, first glance, what do you think? Am I missing anything? Should I, fix something real quick and then resubmit? Sometimes if you have a good relationship, they'll say, hey, I noticed you left out, a discharge error sensor on all the VAV boxes. And then that could be a quick fix. We can fix that real quick. We can go ahead and update our control drawings, submit it. And it doesn't have to be like a long process where we have to wait a week till he looks at it and then gets back with a rejected submittal. Okay, and build relationships or the reputation for submittals that are clear, accurate, and on time. Okay, this is what's going to help repeat business for your company. All right, a lot of engineers might not spec your product or your company. You might not be allowed to bid projects if you have a consistent way of not producing clear or accurate or on-time submittals. Maybe you're always submitting them late. Maybe they're always very inaccurate and they're having to do extra work every time, or it's just unclear and messy, and they don't want to go through stuff like that. And this can just lead to repeat business. This just doesn't be involved with mechanical engineers. This can be building owners too. You can have a building owner, if they see that you didn't submit accurate information, they might not want you bidding any more work on their job site. So these relationships really matter with engineers and owners who are getting our submittals to guarantee that we're going to provide what they wanted the requirements to be from the beginning in the design process. Okay. All right, we do have one more section that we'll talk about real quick, and this is just some digital tools to help streamline the process. We'll kind of talk about that. So there's software out there. There's stuff called Bluebeam Review. I mean, you can use AutoCAD Lite whenever you're using these software tools, or Revit, maybe for markups and coordination. PDF hyperlinks and bookmarks are good to use whenever you're making your submittals. Any type of Word document. That just helps them with fast navigation on very large submittals to get to the place they need to go to. Also, there's some cloud collaboration tools that I'm sure that's out there for version tracking and engineer review, and then also comments. Use naming automation for file consistency. Okay, so the project number, make sure that's on there, the submittal number, and then also the date. Digitally stamp each revision with approval or review for status and traceability, and then keep all your digital archives. It's for easy retrieval. This can help support the warranty process. If there's any questions during warranty, they can always look at that and get that information for your service department, or maybe even O&M documentation a little bit later. If your owner needs to know how a specific sensor works, they'll have those data sheets with them. Okay, well, it looks like we're getting to the end of our time here on the podcast, so I'm going to go ahead and wrap up here. So thank you very much for listening to the Smart Buildings Academy podcast. We hope you learned a lot from this episode. If you found this episode valuable, please leave us a 5-star review on Apple Podcast or Spotify. If you're watching this on YouTube, please like, comment, and subscribe. And as always, this episode will be available on our website at podcast.smartbuildingsacademy.com/517. All right. Well, thank you very much for joining me, and we'll talk to you all next week. Take care and goodbye.